Hi everyone, and you're very welcome to this ASHRAE Ireland webinar on the use of data analytics to deliver ESG for high-tech manufacturers in Ireland. We're delighted to welcome Mr. Paul Walsh, who is General Manager for CIM in Ireland. So before I hand over to Paul, I'm just going to run through some housekeeping and some general introductory points about the webinar. Paul will go through his presentation, and then we'll have some time at the end for a Q&A with the audience. Then just before we finish, I've just got some brief closing announcements before we finish up around 2 o'clock. We will also be taking some polls during the webinar, and I'll explain as we go about how you can give your feedback on those. So everyone is on mute by default, so if you do have any questions at any point during the webinar for Paul, please use the questions tab. You can do that at any time during the presentation, so you don't need to wait until the end. Feel free to submit them at any point during the session. If you are having any difficulty or you want to follow up afterwards, you can email myself, or you can, I believe Paul, you might provide your contact details if you want to follow up directly with Paul afterwards. But also just like to highlight the handouts section of GoToWebinar. So if you look in the handouts tab, you should have access to PDF copies of today's presentation material from both myself and Paul. We'll also make these available later on our website on the webinars page. Lastly, just to highlight, we will circulate a survey that will pop up at the end of this webinar, where we'd really appreciate some of your feedback, just to help make future webinars, just to feedback into future webinars for us. So this is part of our ongoing series of technical events and training that we've held throughout the course of the last year. As you're probably aware, we've moved all of our events online since the beginning of COVID, and we've seen fantastic success with this. Actually, we've been able to introduce a lot more international speakers as part of our ongoing series, and also increase our reach to a wider membership. So rather than having just local events, we've been able to have these online sessions, and I think that's an approach that we'll continue to do going forward. And even when we do go back to hosting face-to-face events, I think we'll still offer this hybrid approach. For any of the previous webinars, you can access the videos on our YouTube channel. The links are on the PDF slides that you can download. So please do have a look at those if you haven't had a chance to join any of them previously. This is also complemented by the ASHRAE Learning Institute, which provides CPD and training from ASHRAE in the US. So you can register for various courses and seminars directly on the ashrae.org website under the professional development section. So without any further ado, I'm going to hand over to Paul. Paul is currently leading CIM's European expansion, and is General Manager for CIM in Ireland. And today Paul is going to be talking about the use of data analytics and how you can leverage that to offer ESG benefits, particularly focused on high-tech manufacturing industry. So Paul, I'll hand over to you. Do yourself more justice in being able to introduce yourself. So I'll just make you a presenter and hand over to you.
Thanks, Dan. And thank you for the opportunity to speak to the ASHRAE chapter today. I've been at a few of your seminars. Yeah, I know you do great work, so I look forward to chatting to everyone today. Can you see my screen now?
Yeah, perfect. Thanks, Paul.
So, right. So just I said a small bit about me. Dan, you gave me a very flattering introduction there, so I just won't dwell on it too much. But David, my brother, is the CEO of the company, and he set the business up in 2015. And my mother reckons that's how I got the job of heading up the European entity that relates to the boss. I'm based in Tipperary, so I'm a big Tipperary GA fan, both hurling and football. I do a bit of cycling as well, and I put social in there because I'm not a very good cyclist, but I certainly enjoy the crack out on the bike. I am genuinely motivated by climate change. I call myself a climate change warrior as opposed to warrior. I have become vegetarian in the recent years as a measure of trying to reduce my carbon footprint. So that's why I suppose I do enjoy work for CIM, because we do deliver demand side reduction for some of the large manufacturing clients that we work with. And I hope to talk the audience through how that happens and how maybe some of the data analytics could help transform what some of you guys are doing. So the agenda today, I'll try and make it as interactive as possible, so it won't be like death by PowerPoint. We'll try and have a few audience polls in between the topics. But firstly, I'd like to give you a quick overview on CIM, talk about some of the problems we see right across the high-tech manufacturing sector, not just in Ireland actually, but right across the world, and how data analytics can provide part of that solution. And then talk specifically about how it aligns with the data-driven asset optimization that some might resonate with the audience here, and what I believe to be the secret sauce in the whole equation, and then some key takeaways. And as Dan said, I'm going to shut up after maybe 35 minutes and open it for Q&A. And I'd love to hear some questions or some feedback or some lessons learned from anyone that's on the call. So just in terms of CIM, the stats are all here on the right-hand side. I suppose the big one that jumps out for me is that we are beginning to get deployed globally now. We originally started in Australia in 2015. When we brought it to Europe, we got some clients that are based in the UK, some in mainland Europe. We also got a beachhead into the US now recently. So it's beginning to grow rapidly. And it sounds, what it feels like to me, certainly as leading up this business, is that there's now a pull from companies for our technology or for data analytics, as opposed to us trying to push a sale at them. They're reaching out to us, which is an interesting change in the market. So I suppose the first thing I'd like to ask the audience, as they say, is just wondering the level of data analytics that your company currently uses, and if you do look at it, or if your company uses it to evaluate the reliability of critical HVAC plant. And Dan has shared a poll there. If you guys could just click on one of the options, it'll just give us some indications of what your company is doing or not. It's only for a discussion point, don't worry. Chatham House rules and all that. So we'll just give it another few seconds.
Yeah.
Is it working, Dan?
Yeah, working. Just got about 60% voted. So yeah, if you can, we'll leave it open for a couple more seconds.
Okay.
Okay.
Cool.
Right. Close it
Oh
there.
yeah, the results there. Yeah. So interestingly, the majority of people say sometimes, and the next biggest sector is in the no sector. So it's about 80% of people are only doing it occasionally or not at all. So that's an interesting finding. Right, so the next slide then, again, can you still see my screen, Dan? Is that okay?
Yes, perfect.
So this is just to outline, I suppose, some of the problems and why it's difficult for engineers to identify the operational efficiencies that everyone knows exists, right? And again, this is pretty broad brush strokes, but it's common to a lot of the large complex sites that we see, right? And I'm sure it's common to the industry. So the legacy system refers to what we see as a myriad of old and new technologies, limited interconnectivity, and then a lot of data residing in silos on site. So you could have a BMS, most sites do have BMS, but you could have an energy metering system, you could have an environmental management system, you could have production systems or production equipment, and again, all the data is residing in individual silos for those data sets. The multiple vendors, I suppose, is referring to what we see. A lot of the large manufacturing clients are outsourcing a lot of the maintenance and upkeep of the critical plant and equipment. So just making sure that the contractors are working. What we see now is they're working in isolation and they don't really have a common goal, and they're not always, now it's not always the case, but they don't always have a common direction or guidance. The transparency, I suppose, referring here to proprietary systems, whether it's the BMS or energy metering systems or a CHP or whatever it is, but it has a proprietary system. So you've got to get that vendor back on site to access the data from that system or to extract data from that system. And in our opinion, that's an example of where the supply chain is broken. It's very much a case of the mouse guarding the cheese. and it leads to slow decision making, again, what we see across the businesses. The breakdowns, I suppose, refers to the fact that a lot of the identification when plant and equipment is going to fall over is often in data, and there's trends there and patterns that would indicate that the plant or the equipment is running outside of its control parameters, design parameters, and it's going to fail. And using data analytics to do that can help. The cost, obviously, energy has ratcheted up. I was talking to one site yesterday, said they've experienced a 3x gas price increase in the last, I think they said 3 months. So it's really becoming a significant pain point for a lot of clients. And resources, right? I think everyone here on the call will identify they're probably looking at this webinar while grabbing a sandwich and eating soup or drinking soup, just to try and pack in in what's already a very busy day. So engineers typically don't have time to do this type of analytics. And then I suppose we see a lot of the large manufacturing clients in Ireland are committed to a publicly quoted CO2 reduction goal, and they obviously abhor any kind of downtime, so that has to be prevented at all costs. And then on the back of COVID, everyone wants to see how they can make their building more profitable. So this kind of compounding what these problem statements are we have seen. And I suppose how, in our opinion, data analytics kind of helps solves these. The data-driven operations refers to the digitization of multiple sites. It's unlocking the data, reviewing data hygiene, blending different data sources, allowing that comparison to be done, and then presenting that data back in a structured and easy to access format. The improved collaboration is kind of bringing all the teams together through a single pane of glass. Everyone then is working towards a common goal and then working with one another in a lot of cases. The FDD stuff, fault detection diagnostics, I suppose what that does is it blows open any of those proprietary systems, in that it flags and prioritizes issues. It provides clear guidance and a path to rectification, including the benefits of doing so, the kind of the what, the how, and the why. And the proactive maintenance is about getting out ahead of breakdowns. The data, as I said, can guide you. The poorly performing compressors, the passing valves, poor pressure control, all these are indicative of problems that will cause a downtime issue at a future date. The reactive capex there, again, it's, I suppose, aligning with the cost, but it just the data allows the site to deploy capital in a smarter fashion, and that means that if the site is earmarking money to replace plant and equipment, it's how best to use the data to guide those decisions, instead of depending on a supplier telling you that the chiller is 10 years old and needs to be changed, as an example. And then the thermal conditions is around the limited resources, I suppose, making sure that everyone's on a safe return to work initiative at the minute, and just ensuring that, you know, if a site is on full fresh, or if it's looking at CO2 sensors to ensure that ppm doesn't go below a certain level, that is done in the most energy efficient way possible. So hopefully that'll outline how data analytics can help. And what I tried to do here is paint a picture of how data analytics works in a high-tech manufacturing site. And I suppose the good news is that all the sites that everyone on the call is working on are already generating gigabytes of data, whether it's from the BMS or from an energy metering system or from any kind of on-site generation or compressed air systems or anything, right? There's plenty of data flowing in most sites, in most large complex sites. How data analytics can help, in our instance, we have what we call a peak platform, but it's a data analytics platform. The first step in the ladder really is around the digitization of these assets, and it's about getting the data cleansed and getting it normalized, getting it into 15-minute intervals, making sure we're not putting rubbish in, because you just get rubbish out then, as everyone knows, and then making sure that it, as I said, the data from the various systems is unlocked and merged at the cloud level. And this is where the software sits. In our instance, it sits on a cloud AWS platform, and this is where the analytics is run across the data set. And what this looks for, or what the rules look for, is times when plant and equipment is not operating the way it was originally commissioned or the way it was originally designed to run. And we know that from getting copies of FDSs, commissioning reports, O&M manuals, single line diagrams, whatever we can get from the site. As part of our commissioning of a new site, we map out how the site should be running, and then we compare it, or if the software compares it to how it is actually running, and it generates a series of faults. And that's what the automatic analysis is there. What in CIM's case happens next is that we have a team of technical HVAC engineers, and what they do is they review and prioritize the issues that the software is identifying, because the software is intelligent, but it's not intelligent enough to prioritize the key tasks to go after. So I suppose there's a key feedback we get from sites around, we have BMS alarms, but the BMS alarms are just becoming a nuisance every day because the facility technicians are getting hit with a tsunami of alarms that they just tend to ignore because they just can't get to them, right? So what the human interaction here is doing is it's helping prioritize and triage the issues that the software identifies. And the last piece here is kind of where the rubber meets the road. It's bridging the gap between the identified savings and what the site can actually realize. And how we solve that at our site is our engineers collaborate and engage directly with the technicians that are on the coalface on the site to resolve what the software is identifying as an issue. And that optimization then happens on the site. And this is an iterative process in that it happens every 15 minutes, and it links in lovely with a lot of the energy management standards. So some sites will be certified against ISO 50001, and there's a plan, do, check, act kind of framework in that. And this kind of framework dovetails perfectly with that. And auditors really like to see this type of a continuing improvement platform being deployed, because sometimes, again, the sites I've worked on, we can get technical experts in to fix or to optimize the chill water system as an example. But when that expert gets in his or her car and drives home, the system begins to creep again, normally very quickly. But what I suppose dataanalytics does is picks up any kind of deviation in real time and prevents that savings from degrading over time. Yeah, and again, this is a kind of a diagram showing the type of information or the type of data sources that we can unlock, and it starts on the left hand side. The HVAC is our primary value add to clients, and if you think of the large high-tech manufacturing sites, a big portion of their energy consumption is consumed on HVAC because they're trying to maintain GMP or GXP conditions to manufacture product, and that can often be quite expensive in terms of an annual energy bill, or it can be a big portion of their energy bill if things like free cooling are not an option if you can't bring in fresh air. Other plant and equipment that we're beginning to get data from is stuff like compressors. Some sites we work with have their own on-site nitrogen generation, and some have on-site generation systems as well. And then there's bespoke process equipment. Now, we don't, just to be crystal clear, we don't play in that space. We don't optimize process equipment because it's very specific to each site we work on, but we can, in some instances, we can get data from that, and we can understand, or we can use it for the client's understanding to see what's driving the consumption of critical plant and equipment. Chill water being an example, compressed air being an example. It's marrying that consumption to what the process equipment is requiring. And then we link in with energy metering systems as well. If the site has one, we get data from all these significant energy users, and any mechanical metering the site might have as well, such as gas and water or compressed air or steam, whatever those mechanical metering. All that data is ingested. We have a device called a baser, which is a data acquisition device that collates the data at site level. And again, it's a hardened cybersecurity approved device. Plenty of information on that if anyone ever needs it. And that data then is sent out. It's a read-only device, so we don't ever write back into the BMS. Sent out to our AWS software, and that's where the peak platform resides, and that's where our engineers then get involved and help the site get optimized. So now, just to make sure you're still awake, we're going to do another audience poll. So just around, the question is, if your company uses data analytics to enable a condition-based preventative maintenance program. So this is, I suppose, the difference between the scheduled and the condition-based maintenance program. And if you are, or if you're planning to, or if you're not, again, it's just to get a flavor of what the different sites are doing.
We'll leave this open just for 10 more seconds or so.
Yeah, perfect.
Okay, we'll close it there.
Right on. So 25% of the attendees do, which is great, and 13% are planning to, and 63% are not right now, which is interesting. But at least some people have started the journey. Great to see. The next part I'll talk about is really how about what data analytics, how it can be used to deliver this asset optimization, specifically in the HVAC side. What you should be expecting from a data analytics solution. What some of the software, like what good software should be doing for your sites. In theory, it should be running across that data in as near as real time as possible, and most BMSs are programmed to 15-minute intervals, so that's probably as near as real time as we can get. It should be automatically identifying operational efficiencies. There shouldn't be any engineers required to sit in front of screens to diagnose when things are wrong. It should have a comprehensive rules database, and this is fault detection diagnostic rules. There should be a big library there, and you should be able to build bespoke rules. So some sites have very specific plant and equipment that is generating data. So a good FDD platform will allow that data to be merged onto the platform, and then rules to be built around that, and without having to involve the software engineering team. Yeah, and I suppose what the output from the data analytics platform will be is obviously energy and CO2 and OPEX reduction. That's kind of the first cab off the rank, in that when you get plant and equipment to operate as it was originally commissioned, you typically get a step change in a reduction in the energy consumption that plant and equipment is using. And that's a lot of time gained from recommissioning plant and equipment. And the data-driven maintenance, which is the previous question, it's just, I suppose, talks about the efficacy of PMs and how to improve them based on the data, and moving to the condition-based programs. Smart capital planning is about using the data to inform how best to deploy capital, and also about getting the most out of what you have on site. So deferring that capital spend rather than having to spend this in the next 2 years or whatever. And equipment performance. So again, that should be a key outcome for anyone who's deploying a data analytics solution. So it should obviously decrease any unplanned downtime, and it should ensure that GXP conditions are always maintained, because we don't want to be causing any kind of quality issues, but they should be maintained in the most efficient way. And what I'm going to do next is just talk about some examples, if that's okay, and then I'm going to show you guys a quick video, which is the an actual talk, one of our engineering managers talking through the one sample that we found. So this is an example of an excessive run hours. You can see it's for an office area, which is non-GXP, but it's just looking at something basic, which is supply and extract fans and the run hours. And you can see that a lot of them are running 24/7 here. So what we were able to, really quick win here, but we were able to implement a revised time schedule, and it saved the client about €3,000 per year on energy, about 30,000 kilowatt hours per year in electrical energy. And again, it's a small, quick win, right? But it's amazing how when data analytics is deployed, how you find a myriad of small issues, but when combined, they add up to a significant energy savings. The second one talks about stop starts on compressors. We see it on compressors on chillers a lot, where there's an awful lot of stop starts happening, and in this particular one, I think it was happening up to 6 hours after hours. So there was no load, but it was still starting and stop. So we just worked with the chiller vendor in this instance to tighten the control logic, and we saved that client about €4,500 a year. And the last one then talks about, I suppose, the balancing the chillers, the run hours between chillers. You can see, I suppose, in this instance, the yellow line here is one chiller, and when it goes up to a 90% load, it starts to go outside its efficiency band. So the objective is for us, and what we did do was distribute the load better amongst the 3 chillers and allow them to individually operate at higher efficiencies, which increased the overall COP. And again, that was a relatively small win for the client. I think it was €3,500, but again, the 3 issues combined there were over 10.5 grand, and they were a low and no cost fix. And what I'm going to do now is just going to jump out for a second, if you bear with me, and I'm going to show you a really quick video of an example of a live action. Let's see. Hopefully it works.
So what I'm going to show you now is production.
Right now,
critical issue that Pete had.
Apologies, it's not showing me full screen for some reason. Okay.
So what I'm going to show you now is a production critical issue that Pete had identified on a site. So essentially the rules alerted us to an issue where the supply air temperature could not achieve set point to, and this air handling unit was feeding a zone that was had strict temperature control parameters. What the rules engine picked up was that the chill water valve went to 100% and the zone conditions could still, or the supplier temperature set point could not be achieved. As you can see here, the supplier temperature was about 4 or 5 degrees above the set point at all times. We raised this with the site team, and the site team reviewed the potential solutions or the proposed solution steps that were put forward by the platform. The first one being check the chill water valve and coil operation, and if that was all good, check the control logic, and if that was all good, then have a look at the sensors, the various sensors that feed into the control. What was found on the first step or the first check was that the strainer was blocked, and in turn there was no cooling getting to the coil, which in turn meant that the supplier temperature set points could be achieved. The impact that was having was that the validated space itself, which had a set point of 20 degrees, was rising up to close to 24 degrees. And at 24 degrees, production would have to be stopped in that area, and there could be potential compliance issues. What did happen was we got to the problem before it became a compliance issue. The zone got back into control and the issue had been resolved.
Okay. Thank you. All right, so I'll just jump back into the deck here. Is that okay again, Dan? You're back. Can you see that?
Yep, perfect. Thanks, Paul.
Perfect. Right, so that's an example of some of the, I suppose, the HVAC issues that the data analytics can find and how they can be resolved. What I'd love to talk about next is, right, if you think about the how we can use data to help any maintenance regimes or maintenance programs, and how we use data to improve operational efficiency over time. And this isn't an initiative to try and get rid of people or anything like that. It's just making sure that if technicians are doing preventive maintenance, that they're doing the most effective preventive maintenance tasks that ensure longevity of plant and equipment or minimize break downtime, whatever the particular parameter is. So, and what you see is sites that are at a current stage, if you like, and after the data analytics is deployed, it begins to inform companies as to how best they can optimize the PM routine. And we see a lot of like, I suppose, legacy issues with PM routines, that they're doing menial tasks like checking if valves are actuating or checking if LED lights are coming on in a cabinet. We even saw one PM that instructed the technician to start dusting down the top of the cabinet, and we kind of said these are really low value add tasks for technicians to be doing. So the objective of a slide like this is to show how the contract reduction can be achieved by using data to indicate when equipment needs to be maintained. Now, obviously, it's not suggesting for a second that we would, suggest a different type of regime that could violate or threaten any kind of warranty that new plant and equipment is under. But set any kind of let's say low and no value add tasks, it would do a better job at identifying where the biggest bang for the buck is. An example here around the smart capital planning, and this is an anonymized example of a client we worked with where we got data from the chiller HLI, and we started plotting the percentage of, or the number of run hours, which is the scale, the y-axis here, and the percentage of time that the chiller was operating in those different, how heavily loaded it was, and the run hours at in each section. And what we looked at was the design COP. So this is what they were sold when the chiller vendor came on day one to say that the COP of the chiller should be 5.8 at 10% load. and it should degrade into 2.8 when it's fully loaded. But what we did is we got empirical data to show the client that what they were actually running at was 1.8 when it was low load. The chiller was basically grossly oversized for what the load in the field was. It began to improve at maybe 20–30%, but it never got above a COP of 3.2. So what this allows us to do is get that data set and plug it into the models for new chiller purchases, and we can use actual data instead of cut sheet data to say this is how it should operate. We can use the data set from the site, typically a couple of years historical data, to say this is how it will actually operate. And this allows the clients to to do that kind of detailed assessment before they have to spend any money on capital equipment. And that's that smart capital planning. And what actually happened in this instance was that the client changed the chiller, but they resized it. And what would happen in a second client case is that they decided that the chiller was running sufficiently efficient that they were not going to upgrade it. Instead, they invested that capital on an air handling unit and on taking out a belt and pulley fan and replacing with an EC wall. And they got a bigger return on investment. They got a bigger CO2 reduction from doing that. And again, it was the same bulk of capital money required. And here's another, I suppose, this is around equipment, improving the life cycle of equipment. And what this one is, it's just a quick example, I suppose, again, but it shows an air handling unit had a static air pressure set point that it could not achieve. And you can see it here that the supply fan was running, this is the blue line at the bottom, was running at 100%, the VSD was running at 100%. And we asked the, in this instance, peak platform identified as an operational inefficiency. But when we went down and when we asked the technicians to go down, it turned out that the static air pressure sensor had just come out of the binder pocket that it was sitting in. So the technician reseated it, and the pressure came back into control, started modulating at maybe 200 pascals. And you can see then immediately the VSD on the supply air fan dropped way back. It went from 100% back to something like 20%. And again, it's just it's an example of how the instrumentation in the field can sometimes and oftentimes be driving plant and equipment excessively. And again, what this was, I suppose, what if you play this out, ultimately, a fan running or a VSD running at 100% will ultimately fail quicker than one modulating at a lower percentage or a lower hertz. And the next and final poll is if data analytics is used by your company around CapEx replacement programs. I'd love to get some feedback as to how true that statement is, or if it is a case. Or do you depend on consultants or on OEM vendor? So there's yes sometimes and no. Okay, pretty even split here, actually. Maybe give it another
10 seconds or so.
Perfect. Okay, cool. So it's 40% sometimes and 40% no. Oh, it's an even split now. Actually, there's been a late addition, so it's right across the board, 43% across each. So that's good to know, as some clients are using data to drive their capital decisions, because capital investment decisions, because it's exactly the right way to go. So thank you for that. Right, the next slide then. So again, this is where and we're getting to the finish here, but where I genuinely believe that data analytics can be a game changer, and what I believe to be the secret sauce within that. And it's genuine. It's really, I suppose, based on first-hand experience, but I've seen plenty of sites that have multiple platforms, and we know facility managers are already extremely busy. They're time poor. They're in that reactive mode. They have an element of platform fatigue. They don't want another report sent into their inbox, adding to the multiple projects that they never get to do. What I see is the synergy in all this is the ability to merge the software with technical experts, and I suppose what that, in this instance, using fault detection diagnostic software, it delivers for the outcomes. It delivers that immediate demand side reduction, whether it's on energy cost and ultimately CO2. It also gives the technicians a new impetus, we've seen, because technicians, typically facility technicians, are used to getting kicked in the face a lot of times. Or every time there's a problem, facilities are blamed, or call facilities when 4 o'clock on a Saturday morning to come in and fix a chiller. So they're constantly I suppose, reacting. So the ability to help them get out ahead of problems empowers them and allows them to be painted in a good light, which is very impactful from a people perspective. And again, it upskills on-site teams, and that's not to say that they don't know what they're doing, but it just changes the energy literacy on site, or the energy awareness. So it's leaving things in hand, or overriding set points, or not fixing instrumentation that's faulty. Just making people aware of the potential impact from that from a site's operational efficiency perspective. And then that behavioral change is the last point. So again, if the wider technician team or the wider employees see the site now becoming more energy aware, energy conscious, and putting dashboards up in reception and in canteens, they can all ask themselves questions as to how they might be able to help a site reduce their energy consumption. And how, I suppose, the process, this is kind of where I mentioned before, where the rubber hits the road, like how the analytics platform that we own, how that empowers the technicians. And what we have done is developed a very simple to use cloud-based workflow tool where the contractors can, every morning they can access it on their mobile device, and they can just review what the ticket is that has been assigned to them by our engineers. They can either say it's putting it on hold, they're assigning it to a contractor, which might be a contractor that's maintaining the AHUs for them, or a chill water contractor. And then it allows the CIM team to follow up directly with that contractor. So it's a very good way of tracking and maintaining the issues as they're identified. And we open it to everyone on site. So there's a good record of the collaboration between us and the engineers, or us and the site technicians and the contractor, and there's a history there of what was done. And what we do is ensure that if that issue reoccurs, that the history of what was done previously is brought back into the next ticket. And this is really, as I say, this is in my opinion, the magic sauce, because this is where the merging of people and software really happens. And there is multiple examples, I suppose, of how effective this process is. And it's really the modern way we feel to manage buildings. It's smart, it's simple, and it's transparent, and a lot of clients love that. So just to wrap up, just coming up on time, what I would say to anyone is, the good news is sites have loads of data. So we're starting at a good point. And the second point is data analytics, and I hear it a lot, is, we've all the low-hanging fruit addressed. When you go to sites, we've our lights changed to LED, we have solar PV on the roof, we've upgraded our chillers. In my opinion, that's not low-hanging fruit. That's the next stage of low-hanging fruit. The first port of call is just to get what you have operating efficiently. And data analytics, folks, is the key for that, right? It should be the first step in any CO2 reduction strategy, because a lot of companies we work with, and the people on the call work with here, I'm sure, have committed to becoming net carbon neutral in operations by 2030 or 2050. And the companies feel that that's a very capital intensive commitment. But there can be anywhere between a 20 and 25% demand side reduction that can be achieved in advance of either entering a capital replacement program or a PPA, power purchase agreement, or even if you think about it, if you're not carbon neutral by 2030, the cost of buying offsets. Carbon is about 60 euros a ton now. So if some of the sites we deal with are emitting hundreds of thousands of tons per year, so it's going to become very, very expensive unless data analytics helps deliver some of this strategy. And in the collaboration, so this is key, as in our opinion, is just the integration between the site technicians and the software. It's getting, because there's a tacit knowledge in every one of those site technicians. They know that they want to get the site operating efficiently. It's just to help empower them and help unlock the data that they don't have access to and the analytics that they want to deploy across it. And then ultimately what happens is the asset optimization. So again, specifically on HVAC, it starts behaving itself and you get the demand side reduction and the CO2 reduction. So thank you very much for listening to me. I hope some people got some nuggets of information out of that. Happy to take any Q&A, Dan, if that's what you feel is the next thing now.
Yep, perfect. Thanks very much, Paul. Just for attendees, you can post any questions that you have just through the questions tab or box on GoToWebinar. Just while we're waiting, I suppose just start with a couple of questions for myself, Paul. Just at a high level, I suppose we've had COP26 kicking off earlier this week, and clearly there's a increased focus on renewables, sustainability, carbon reduction. And I suppose what role do you think high-tech manufacturing in Ireland has to play in that carbon reduction, and how is that impacting this whole agenda, impacting sustainability among high-tech manufacturing specifically?
Yeah, So I suppose what's happening with COP26 is it's probably helping get this type of sustainability discussion up to this SLT level in a lot of companies. And COP26 just happening recently, it's getting all the headlines. And I think the manufacturing sector, specifically in Ireland, like Ireland has a commitment to be 51% reduction by 2030, which is, I think it's 4.5% per year for the first 5 years, and then 8.2 for the next 5, or next 4, whatever's left. And I think in order for Ireland to do that, because Ireland is so manufacturing intensive, with a lot of the high-tech manufacturing companies being based here, they're going to have to quickly decide what they need to do to align to that carbon neutrality program. So I think it's good, Dan. It's helping change the narrative around the procrastination that we see. Sustainability would be nice to have, but it's too important. We're making widgets, and that's all that matters. They have to now pivot and figure out how they can make them more sustainable. From a competitive perspective as well, because to keep jobs in Ireland, we have to be able to maintain our cost base. So reducing energy makes economic sense as well as sustainability sense, and it aligns. It's two sides of the same coin, in that it will help them deliver against their CO2 reduction and also against improving their competitive cost base. So I think it's a vital step, and I think SEI and companies or organisations like that have a vital role to play here, as do ASHRAE and META and Engineers Ireland and associations like that, in that they can continue to host webinars like this and focus the attention of the engineers to drive the efficiency at their sites. So that was a long-winded answer, Dan. Sorry, I hope it kind of answered.
That's perfect. I think that was clear. So I suppose just following on from that, then on a kind of a practical level, where would you see the hurdles in getting? I mean, we saw from some of the polls there that maybe it's at the moment, at least, it's not so common to employ advanced analytics on site. So where do you see the biggest hurdles in implementing these types of systems? Is it at a technical level? Is it finance? Is it the human component, or is it a combination?
I suppose what we find the biggest hurdle, because with a model like ours, we have it as an OPEX only, so there's no capital needed. So we've tried to grease the slide for a lot of sites to deploy our data analytics platform. So I suppose where we see the challenge, if I'm being honest, where we see the challenge is the engineers that we are selling to, or the facility managers we are selling to, are so busy in that reactive mode that they very rarely have time to stop and think and sharpen the saw and look at deploying what would be a strategic initiative like ours, where it could help them, over the longer term. So I think getting the attention of, the intention is the wrong word, getting the commitment from the facility manager to deploy us and just to help us get up and running does take, I suppose, a bit of emotional investments and physical time investment. And I think that's probably the most finite resource now is facility managers' time. I don't think money is anymore, because sites are willing to deploy it, and I don't think it's like the resources that we need. We try and take as much of the heavy lifting onto our side as we can. So I think it all comes down to being able to deliver a real succinct value proposition in a really quick time when you do get in front of these facility managers, and making it as painless as possible for us to be on board. But we have plenty of examples of that. Like, we're lucky enough to be working with a multiple, probably 15 different high-tech manufacturing sites across Ireland now. So it does work once we do get up and running.
Perfect. No, thanks, Paul. That makes sense. I suppose just where once you get a system like this in, I think you kind of hinted at some of the other opportunities that presents, aside from just identifying issues on site. You've also got the smart capital planning. Where would you see kind of the future opportunities once you do implement real systems, or leveraging the data on sites? Do you kind of see a future where you can leverage that more into other areas and kind of increase your return on investment, I suppose, by making that upfront investment in a system like this?
No, absolutely. Like the energy reduction piece of data analytics is only one. As I said in the overview, it's probably the first cab off the rank. But there's multiple other things that data analytics finds. Like we often find safety issues. We find chilled water systems that are pumping at too high a pressure, or we find issues with Legionella, thermal shocking loops. So there's other non-energy value that fall. And the other big thing now at the minute is the safe return to work. So a lot of people are trying to repopulate offices, and how to achieve that, to build back up the trust of the people coming back on site, that the site is adequately ventilated. And by able to show them BMS screens showing outside air louvers at 100% open, they know that they're getting 100% air. Now it's obviously it's an energy challenge to do that, because you're going to have to heat that air and you can't do any recirc, but that's a separate problem in the short term. Safety trumps anything we do, but ensuring clients that are assuring occupants of buildings and people who work in, if you think of manufacturing floors, who worked in areas that are clean rooms, how to deliver optimal thermal comfort for them, so they're not, they're able, and it ultimately affects their productivity. If someone's working in an area that they're too hot or too cold, they cannot concentrate on their job. They're continually, annoyed with that setup, and they're giving out to maintenance. They're not happy in their role. So even attrition doesn't, it can negatively affect that. So this is again what data analytics can do. It has all these additional value adds, and where CIM is going as a company is we're moving more into the artificial intelligence and machine learning space, so we can begin to understand best practices across multiple manufacturing sites, and bring benchmarking to new sites that we go to. Say this is industry best standard as to how your air handling units should be operating. Let's see if we can come up with a federated learning type module that would blend data from multiple sites and allow best practices to be disseminated back to those sites without violating any kind of company privacy. It's just, I suppose, collaborating, not competing when it comes to that CO2 reduction. And that's where we will be going as a company over the next few years, because we want to continue to differentiate our product offering.
Okay, thanks, Paul. Just on that predictive element and benchmarking against sites, I suppose you talked about the smart capital planning and being able to benchmark performance of existing systems. So it gives you, I suppose, a better prediction of how you expect a new system will perform on a site, more than the initial design expectation, I'll say, and that's, I know, been raised a lot, the whole performance gap issues in buildings in general, not just in manufacturing. But do you see, so I was kind of curious if you see opportunities there in offering more certainty, and I'm thinking in the type of energy performance contracting and things like this, where you want to minimize risk. Is that something that you do with clients? Or
well, we don't do those energy performance contracts or those shared savings model. We try and get as much savings as we can for a fixed fee and maximize the savings for the client. But I'm aware of them, all right, Dan. And I suppose what we see, even we have a lot of buildings on the platform now that are new builds, right? They're literally less than 24 months old. And I suppose what we see as a general issue in the industry is and again, it's going back to the supply chain being broken, is that you often have buildings that the BMS is commissioned by the BMS vendor. So it's very much a case of someone checking their own homework. And oftentimes the building can be handed over to the operator or the FM company or the FM team, and the building is not running properly from day one. So a lot of the buildings we see now is, and where we add a lot of value is actually, ensuring that the building is running as per FDS. And if it's a new building, there's no reason it shouldn't be. And a big issue with buildings is because the commissioning is typically done at the 11th hour, and everyone is screaming at the BMS vendor, just get a commission, we have to move in next Monday. The BMS vendor is working over weekends and condensing the commissioning time into a really quick period of time, and he or she is not incentivized to flag any potential issues. So the building is handed over running inefficiently from day one, and that's where we see a big problem in the marketplace right now. And I think what's happening more and more is independent commissioning agents are helping blow that wide open, and URSs are becoming more tight at the building design stage to ensure that the building is LEED Platinum, that it's actually certified as LEED Platinum in operation rather than at design. You know, because having a building certified at design is totally different to what you get handed over, unless you get some piece of paper. And as I said, our headquarters are based in Australia, and in Australia they have a very good operational efficiency scheme. It's called NABERS. It's NABERS, and it's National Australian Building Energy Ratings Scheme, I think. And what it is, it's basically an annual review of how efficiently, actually it's not even annual, it's real-time review of how efficiently your building is operating. And your building has to be above, and building could be a manufacturing facility as well, but it's got to be above a certain threshold before the building can be rented or sold. And that gives the building owner a very, you know, a dog in the fight at this stage. So they have to ensure that the building is commissioned correctly and then it's operating correctly. And that's a very good scheme. It has worked to be, it has proven to be transformational in Australia, and there's talk about bringing it into the UK. It'd be great if a system like that came into Ireland, and I'm just not sure of the possibility of that. But I think that to answer your question, the benchmarking part of it is key.
Yeah. I suppose just before we close up on the Q&A, I have another question that's maybe more on the technical level. So I appreciate if it's
give it a go.
We just following on from, I know we had a presentation last week that was looking at different schemas and ways of mapping data on site. So and one of the difficulties that was highlighted was the different naming conventions that you come across, especially on manufacturing sites, depending on who did the initial installation commissioning. So how ready do you think most sites are for implementing a system like this, and is there a level of transition required in kind of mapping and normalizing the data before you can really unleash the power of data analytics on the site?
Yeah, so it's a very, very good point. We see that issue with naming conventions every day of the week being an issue. But what I suppose what it has the effect of doing from our perspective, Dan, is it just makes the commissioning of the site longer for our engineers. Now, internally, we've developed an artificial intelligence algorithm that, you know, searches all the points, and it looks for things like AHUs or VAVs or FCUs, and it starts doing kind of meta tagging on those type of tags to speed that process up. Now, you're right. You go into one site and it'll be called AHU 0104. You go into another site, it's called air handling unit. You know what I mean? So it's different naming conventions and different challenge in each site. So again, it would be great if it was standardized. It would allow the deployment of data analytics to happen much faster and much more seamlessly, because the data hygiene piece is huge, right? You know, the digitization that I spoke to there, that can often be the biggest nut for us to crack. It can take ages to figure out, you know, what the name of a particular tag is, and especially if the site is old, if it's commissioned in 1995 and there's a tag name there and nobody knows what it is because the technician has retired and the O&M manuals are not available. So there's it slows down the onboarding of sites and the commissioning of sites. But I suppose we get around it, but it tends to be a manual problem, and it's not ideal, but it can be fixed on a site-by-site basis. When we deploy across multiple sites, it does, as I say, become a problem. But the quicker we can standardize on that, and I think Haystack and things like that are helping that. So it'd be great when that does become industry standard.
Yeah, no, it's great to hear, and there's, I mean, this and some of the other presentations we've had have kind of highlighted the value of data and buildings and the different services that you can deliver once you do have that kind of normalization and availability of data. And there is efforts ongoing within ASHRAE and other organizations to kind of help to standardize that. So they were talking about this brick schema last week, and which I think could go a long way to helping that effort. Yeah. So I think, just in the interest of time, I had a couple of closing announcements. I might just switch back to my screen. Just give me a second.
Sorry, did you stop? No, you got it. Thanks.
Okay. Can you see my screen?
Yeah.
Yeah. Okay. Just making sure that's okay. Yeah. Okay. So just before we finish up, and just in relation to CIM, and I'd just like to thank Paul again for your involvement in sponsoring this mentorship program that we're launching later this month. It's something I'm really excited about, and I know the rest of our board and ASHRAE are really excited to be launching in collaboration with CIBC Ireland as well. And the idea with this is that we're launching this mentorship program to assist young engineers at the early stages of their career by pairing them up with more experienced mentors in the industry, and specifically in the HVAC and building services industry. So, as you know, I suppose graduates and young engineers coming out in the last year and a half have had a pretty tough time in furthering their careers, you know, by being constrained and not being able to attend events and meet with people, network, etc., which is, as we all know, is a key part in career progression. So we'll be holding our first open event on the 25th of November, and we're still accepting applications and expressions of interest for both mentors and mentees as part of that program. And you can apply to that through our website. I don't know, Paul, while you're on, if you wanted to say any couple of words, you're welcome before we close out. But
yeah, no, thank you, and we're really looking forward to that mentorship program as well. Dan, we have a lot of senior engineers that want to impart some of the, share some of the scars off their back and prevent young engineers from incurring the same pain we did. So yeah, we're delighted to be involved with it, and we look forward to a good uptake on the 25th of November. Yeah, thank you for the opportunity again.
Thanks, Paul. Yeah, last couple of slides, I've just highlighted our current board for this year. As always, if you're interested in getting involved, do reach out to any of us. Our contact details are all on the website on ashraeireland.org. Our social media channels, etc., where you can follow all of our upcoming events. And as I mentioned at the beginning of the call as well, all of our previous webinars, technical events and webinars are available online on our YouTube channel, which you can subscribe to through the link on this slide. So that's it for me. Just lastly, just to say a word of thanks to all of our sponsors and supporters, and sincere thanks again to Paul for your time today and for a really interesting presentation. Yeah, that's everything from us. Thanks very much, everyone, for joining, and enjoy the rest of your evening. Thanks very much.
Thanks. Bye-bye.
Bye now.